So I thought that the first thing that I want to do would be to talk about this one, okay, the transmission of electricity. But this one maybe doesn't really have much to do with the syllabus. But I thought that it's very interesting that you should know that in Sabah, okay, kalau di Sabah, I found out lah, where saya pernah bawa budak pergi field trip. We went to a generating power station. And I realized that when they step up the transformer, they only stepped it up to 132 kilovolts. Okay, then they send it out to this one. And so the reason behind that, apparently, the reason behind that is because in Sabah, there are not that very many heavy industries. And because Sabah is dia sangat luas kan. Sabah is so big, so there are different places that have different generators of electricity. So there's a few in KK, and then there's a few in Sandakan, a few in Tawau. So those places are responsible for the distribution to that place lah. Okay, so because of that, they don't have to send the electricity so far. Okay, so they don't really have to go all the way to 275. Okay, and they only step up the voltage to 132 kilovolts, and then after that they send, and then the main distribution substation, and then they send it to 33 kilovolts, 11, and then 230 volts now. Okay, I thought that was very interesting to know that in Sabah we only step it up. That means ini langsung tiada ini. Okay, the generation electricity kan, the moment they step up to 132, and then they send over to the main distribution substation. 132 is still very high lah. Okay, and again, the reason why we send it at very high voltage is to decrease the current, because when the current decrease, then the power loss will decrease. You cannot do much about the resistance lah, except that kita mau guna thick copper wire or thick wires lah. Okay, but that's about it lah. You can't really change much in the resistance. So what we can do is we can change the current. So I wondered lah, but I don't think I have the answer now. I wondered kenapa kita tidak just naik pergi 275, and then lepas itu kasih turun terus pergi 33 lah, why 132? I'm sure there's a reason for this lah. Okay, but unfortunately, I'm not the right person to ask lah. If you want to know, you have to ask somebody who works in either SESB or in a power station lah. Okay, but what I want to show you now, so this video, so this is the back part of the power station. So each of these corong over here that you see, okay, is a generator in itself. Okay, and so when it generates electricity, this is a power station yang menggunakan diesel. Okay, dia menggunakan bahan api diesel untuk menghasilkan tenaga elektrik. Okay, it produces electricity by electromagnetic induction. Okay, so what happens is the burning of the fuel akan memanaskan air, and air akan menghasilkan steam yang berkelajuan tinggi. It will be high speed lah. So the high speed steam will turn a very big fan, okay, yang bersambung kepada satu generator. Remember, for electromagnetic induction to happen, okay, you must move the thing. Okay, kita mesti bekalkan satu pergerakan inside a magnetic field so that you can induce the current. Okay, so everything in subtopic 2 and subtopic 3 works in this lah. Okay, so again you burn the diesel, sorry, kamu bakar itu diesel lah, okay, and then it becomes fire, and the fire will be used to heat up the water. Okay, water will change into steam, steam at high speed lah. Okay, there is something else that goes in there that makes it high speed. So the steam at high speed will move a fan. Okay, they will move a fan, or otherwise known as a turbine. Okay, a turbine lah. So when the turbine spins, okay, bila turbine itu berpusing, and this is where your generator explanation comes in lah. When the fan spins, it will move a coil that is in the permanent magnet. Okay, and that will cause and induce current to be produced. When the induced current is produced or the induced EMF is produced, the voltage will be transformed, will be stepped up, and then it will be sent. Okay, so all these wires you see here are already voltages that are already stepped up. So this over here, I don't know if you can see this. This is the transformer lah. Okay, but take a look at this. You can ignore the voices of the video lah if you want. Oh, sorry. Hold on. Okay. All right. So this is a transformer. Okay. This is a step-up transformer. You can see this guy is sitting over there, right? You can see how big the transformer is. That's how big the transformer needs to be in order to step up the voltage to 132 kilovolts. Okay, so yang biasanya dihasilkan, if you remember from this one, yang biasanya dihasilkan is just 20 kilovolts. Okay, 20 kilovolts of 20 kilovolts lah. Okay, voltage. Okay, you step it up, but in this case of this power plant, it's stepped up to 132 kilovolts. Okay, so you're talking about, you're talking about kalau kamu guna pen, 20 to 132. Sorry, it should be 132 to 20. Okay, 132 to 20 is about maybe six times, 6 kali lah dia punya 132 divided by 20. Okay, it's about 6.6 times. Okay, 6.6 kali lebih besar. They step up 6.6 times lah. So that's why if you see the transformer is huge, you know. Okay, so as you see, the transformer is connected to these transmission wires. So each of these wires is carrying 132 kilovolts. I'm not sure whether it's each wire or whether it's a combined. I think it's combined, they carry 132 kilovolts. Okay, but again to point out just how big the transformer is. Okay, take a look. This is the transformer. Okay, that is in the power generating factory that is used to step up the electricity. That's how big this is, you know. Okay, even in the substation. Okay, so this is another video.
So ini adalah transformer. This is the transformer.
So dia hantar. Okay, so one thing interesting that I found out when I went to this power station is that over here, the power station is milik company tersebut lah. Okay, so the company that provides the electricity, provides the power, okay, their responsibility is to step up the voltage, and then kalau kamu nampak, once they naik to 132 kan, okay, you notice that this pagar over here. Okay, this fence over here, okay, so this fence over here, these are all the boundaries, you know. Beyond this fence, all these poles, all these things over here yang terletak di luar ini, this belongs to SESB. So it's quite interesting. I mean, it's quite interesting when we went there to find out that, oh, okay, so the power is generated by a certain company, usually it's a private company. This particular company is called Randhill Power Plant. There are quite a number of power plants in KK. In KK alone, there are quite a number of power plants, but the only one that we went to last time was Randhill Power Plant. So Randhill Power Plant is in charge of producing the electricity. Okay, then dia kasih step up, okay, on the transformer that is still on their side. Once it is stepped up, it will be sent into all these transmission towers, okay, which already belong to SESB. Okay, so I thought that was quite interesting. Macam dia transfer of power lah. Okay, transfer of power from Randhill to SESB. Okay, so that's why there is a pagar over there, so that the boundaries are very clearly. Okay, ini bahagian kami, ini bahagian kamu. Okay.
So ini adalah transformer. This
Okay, so yeah, again, now this is the transformer. Me asking a very obvious question. Okay, so he's saying that when he send, it is already 132. Okay, 132 means 132 kilovolts. Okay, so maybe at this juncture, some of you are asking, who decided that it is 132 kilovolts? Okay, so this one is a very long question for another time. I think if you want to find out, there is a certain formula that they use. Mengambil kira semua keadaan kan, and they realize that, okay, 270, 132, these are all good numbers to step up your transformer to. Okay, but why? Let's not talk about this today. Okay, so this is another one. So this is the SESB substation. Pencawang SESB in Tanjung Aru. Well, near the Tanjung Aru lah. Actually, dia nama Tanjung Aru, tapi sebenarnya dia berdekatan dengan airport lah. Okay. So, okay, so what you are seeing here, sorry. Okay, so what I want to show you here is, so you see this thing over here, okay, this part over here, I don't know if you can see the hand now. You know what, I should change the pen. Okay, so this thing over here is daripada yang power station tadi bahkan. So dia akan pergi daripada tiang ke tiang ke tiang ke tiang ke tiang, and then from this tiang it will be sent over here and then sent down to here. Okay, so over here at the substation now, there's a whole lot of other transformers lah. Okay, and the function of these transformers is to step down the voltage some more. Okay, to step down the voltage some more so that it can be then distributed into the various places. So kalau industri kecil, there'll be a certain amount of voltage transferred there, and then kalau industri besar, there's another one. And then kalau kepada perumahan, which is 240 volts, oh sorry, slightly less than that, slightly more than that, sorry, will be sent to this one. So there's, in the substation, there are a lot of transformers, okay, also very, very big size, and the function is to step down the voltage, okay. But again, to show you that, because electricity that is generated di tempat yang jauh, this is in Tanjung Aru. The power plant that you saw just now was in Indah Permai. You know how far Indah Permai is, right? Okay, from Tanjung Aru. So it has to travel a very long distance. Okay, and because it has to travel a very long distance, okay, the wire, okay, is going to encounter a lot of resistance. Okay, and that's why we have to step up the voltage so that we can reduce the current. Okay, when we reduce the current, we will reduce the power loss. There's definitely going to be some power loss. Okay, definitely a bit of power is going to be lost, but to reduce the power loss, we use thick copper wire and we use a high voltage. Okay, we use high voltage so that the current is small and then the power loss will be minimal. Okay, then come down here. Once it comes to the substation, the job of the substation is to step it down so that it can be, distributed to other places. Okay. Okay. Now, this is saying nothing much, but I just want to show you that all these transformers are actually in the substation itself, and they are huge. Okay, they are huge. Each one of these, setiap satu daripada ini kan, dia lebih tinggi daripada saya sebenarnya. Okay, it's huge. So don't think of the transformer as a very small thing. It's actually it's a very big structure lah. Okay, that whether you're stepping up or stepping down, it is a big structure because we are talking about changing kilovolts of power, kilovolts of voltage. Okay, so you imagine how many coils are in the transformer. Okay, bukan sekadar ratus-ratus sudah lah. We're talking about thousands, hundreds, thousands, maybe millions, okay, of coils in that one transformer, so that you can step it up to 132 kilovolts, and so you can step it down to whatever value that you want. Okay, all right. So let's take a look at these 5 questions. And I hope that you've already taken a look at these examples, okay, to show you. Okay, the most important thing is this. Whenever you're talking about an ideal transformer, okay, this word brings this formula to mind. We can only use this formula, okay, if and only if, jika dan hanya jika perkataan ini muncul. Assuming the transformer is an ideal transformer. The word ideal must be there in order for this formula to be used. The input power, okay, equals to the output power. Okay, hanya dan jika hanya saja. Okay, hanya dan jika dan hanya jika. Sorry, hanya dan jika hanya. Jika dan hanya jika saja. Okay, alright. So let's take a look at question number 1. Let's start with. Shall we do it alphabetically today? Oh no, the other day we start with Wilson, right? Okay, Wilson, number 1, please.
50 turns?
50 turns.
Yeah.
Okay, can you okay lah, fine lah, can lah. I just want to know that you did it. Okay, so it's pretty simple. It is the primary voltage and the primary turns, and then the secondary voltage, and then the secondary turns lah. Okay, VP over NP equals to VS over NS. The most important thing is identifying which is the VP and which is the VS. Okay, if of course the big clue is the word step down. If you see the word step down, then you know that, oh, okay, there must be high voltage to low voltage. Okay, and then they will say primary coil is 1000 turns of wire, the number of turns will be 50. Okay, all right, good. Number 2, 2A, can I have Zulaika for this, please?
60 watts.
61. Oh, 60 watts. Okay, very good. All right. So the input power is just VPIP. Okay, 12 times 5 would be equals to 60 watts. Good to hear your voice, Zulaika. Okay, B, Adam. The EMF induced across the secondary coil.
1200 voltage.
Okay, 1200 volts. Okay, you just use this one and you get 1200 volts. Voltage is the quantity, volts is the unit. All right, question C, if the transformer is 100% efficient, okay, maksudnya dia adalah ideal transformer. Okay, so what will the maximum current flow be? Aliska?
Saya salah, selesa.
Kamu selalu salah tak? Kau punya ini salah. Okay, tidak apa-apa. So, of course, it will be VSIS equals to 60 lah. Okay, sebab the input power is 60. Kalau kamu guna VPIP equals to VSIS, okay, it will also be, it will also be the same thing lah. But since the A has already counted the 60 for you, so you just make the VSIS equals to 60. Okay, kita boleh cakap ini hanya kerana the transformer is 100% efficient. 100% efficient means it's ideal, means that input power equals to output power. Okay. Eliska, can you calculate this? VS berapa? VS is how much? VS is 12. Okay, so sorry. Yeah, 12, no. What is VS? Oh, 1200, sorry. Okay, can you calculate IS, please, Eliska?
0.05.
Okay, unit?
A.
Okay, 0.05 A. All right, so even if you get it wrong, don't worry. Okay, we will make corrections, but please make sure that you know di mana kamu salah. Okay, itu yang penting. This is why the tutorial sessions are very important. Okay, all right, number 3. A step-up transformer has a primary coil with 50 turns. Okay, yada. Steps up, okay, step up main voltage from 240 to 12,000. How many turns must there be in the secondary coil? After Eliska is Brendan. No, Angeline.
240.
140. Wow.
240.
240. 240 turns. How can there be 240 turns? Oh. Okay, so we hold on to this now. VP over NP equals to VS over NS. Okay, we substitute it correctly. Okay, Angeline, tell me, what is the value of the primary voltage?
240.
Okay, 240. So that means the secondary voltage must be 12,000. Okay, and then these 50 turns, okay, which one is it? Is it NP or NS?
NP.
NP, okay, very good. So 50. So we're talking about 240 over 50 equals to 12,000 divided by NS. Okay, can you calculate NS for me, please?
2,500.
2,500 seems to make sense. Very good. Okay, so 2,500 is the distance. So again, substituting the correct value in the correct place is the key to getting this right. Okay, all right. B, when the current in the secondary coil is 0.2A, once again, we're seeing this 100% efficient, which means that VPIP equals to VSIS. Okay, Brendan, what is the current in the primary coil?
M.
Okay, then I hope that I heard you correctly lah. Okay, so it will be 10 amps because once you get the 240 is VP and then they give you the IS is 0.2. Okay, so when you calculate, you will get 10 amperes. All right, very good. Number 4, toy train requires a low voltage to operate, yada yada. 600 turns, again the words 100% efficient. Okay, so after a while it's like, so many questions. Why can't we get a question that is not 100% efficient? Wait lah, okay, I'm sure there are questions where they're not 100% efficient. Damir, A please.
20
20 what?
voltage.
I use, kejap. Oh, okay. Alright, 20 volts bukan voltage. Kamu orang ni Okay, voltage. Okay, voltage is voltan. Dalam bahasa Melayu voltage is voltan yang adalah quantity. The unit is volt. Okay, unit sahaja okay is volt. So we say, the bekalan kuasa datang dengan 240 volt. Okay, dia bukan singkatan it's just the name of the unit, volt. Voltage, voltan yang dibekalkan adalah 240 volt. Begitu kita cakap. The voltage that is provided is 240 volts. Okay? Sorry, saya cerewet macam apa ni, tapi make sure you get it right lah. Okay, Daniel, B please. Primary coil current, it has to be VPIP. Okay, equals to the power lah. Okay? So, my first question is, what is the VP?
0.08 ampere.
Okay, 0. Wow, okay, so you jumped it. Okay, 0.08, 0.0. I think you're missing 1 0, right? Okay, fine, 0.083 ampere. Okay, now, so the question is this, how come they only give one value of power? Because, okay, this is the reason why, because when something is 100% efficient, we don't care how much the power is because we know that the input power is equals to the output power. Okay, so if the input power is 20, the output power also is 20. So what Daniel was giving just now, originally the 1 amp was actually the output current. Okay, the input current is 0.083, okay, and the output current is 1 amp. Okay, take a look at this now, everybody. The input voltage is 240. Okay, input, okay, this is the voltage, this is the current. The input voltage, input is 240, but the current is 0.083. The output voltage is only 20. Okay, output. But look at the current. The current is 1 amp. Okay, so it's a very important thing, if the power is the same, okay, the voltage and the current are inversely proportional. When your voltage is bigger, your current is smaller. Okay, and when your voltage is smaller, your current is bigger. Exactly the reason why we need to step up in a transformer before we send it out. Because when we step up, okay, to a higher voltage, we have a smaller current. Smaller current means less power loss. Okay, power loss, kehilangan kuasa is I squared R. Okay, the only formula for power loss is counted in this way. Kita tidak pertimbangkan pun the voltan. Okay, power loss is because of the current that is flowing, okay, and the resistance of the wire itself. Okay, so the current is a very important factor when we are considering power loss. All right. Okay. Good try. Number 5, a multi-tap transformer. So multi-tap. There's a slight mistake over here. Sorry, everybody. This is actually LM. Okay. So a multi-tap. Yeah, that's why I don't see MN over here. Okay, so multi-tap transformer is a primary coil of 500 turns. JK, KL, and LM, okay, at the secondary coil have 30, 15, and 5 turns respectively. Okay, if a primary voltage is 200 volts AC, okay, what is the secondary voltage? So that means in this case, the number of turns is different depending on how far you kasi this one lah. Okay, how far you this one. And interestingly enough, I think that this is last year's SPM question, something similar to this lah. Okay, this looks like last year's SPM question, paper 2. Okay, for calculation. All right. Can I have Elijah for A, Irdina for B, Isabella for C, and Jacinta for D? What is the secondary voltage for each of these?
12 volt.
Okay. So the first one is 12 volts. Second one?
6 volts.
All right. Good. 6 volts. Third one?
2 volt.
2 volts. Nice. And the last one?
8 volt.
Okay. Very good. 8 volts. Okay, so the important thing is the distance. So JK is only 30, and then KL is only 15, LM is only 15, but K to M, okay, is a gabungan of 15 plus 5. Okay, let's do something extra lah. Can I have JM, please? Try to count the secondary voltage if it is all JM. So mengada kan? Why is Sir adding this extra question? Yeah. What if it is JM? What will my secondary voltage be? Calculate now, please. Who is after Jacinta? Jericho. Let's have Jericho to answer this. JM and... Sorry?
20 volts.
20 volts. Okay. All right. I'm going to assume you're correct lah. Okay, and let's do one more lah, just to annoy everybody. JL. Can I have JL, please? Chris Fia.
18 volt.
Okay, 18 volts. I think that makes sense. Okay. Of course, the biggest one, you see, kalau kita gabungkan semua, 30 plus 15 plus 5, right? Then you get 20 lah. Okay, JL is 30 plus 15, you get 18. And then after that, JK, yang 30 sahaja, is only 12. Okay, so this is what the multi-tap transformer means. So that means depending on where you sambung your this one, the number of turns will be affected by it. Okay, so sorry for this mix-up. Okay, this is LM, not MN. Okay, good job, everybody. Let's go to our tutorial session now. Okay, okay, fine. It's okay lah. We can do this together. You can take a shot in the dark, and then we'll see how far we can go lah. Okay, I don't think we can finish everything by today, so we'll finish everything by the next class, which is I think tomorrow. Okay, and then next week we will go into the new chapter. All right, let's continue. Number 1, diagram shows a circuit containing an ideal transformer. Which statement is correct, Lester?
A.
Okay, A. Bulb P is brighter than bulb Q. Why?
Because the coil at the left has more turns.
Okay, because the coil at the left has more turns, therefore the voltage is bigger lah. Okay. In yesterday's video, I don't know if you noticed this, I asked a very important question, which you can do research if you want. Okay, it's a very, very long discussion lah. Apa yang sebenarnya menyebabkan the brightness of the bulb? Is it the voltage or is it the current? Okay, it's a very big debate lah. Okay, and I don't want to go into it. Okay, I don't really have a definitive answer. Okay, but I think it's very interesting to follow the discussion lah. There are people that think that the voltage is the one that determines the brightness of the bulb. Okay, which makes sense because if you think about this, the voltage that is being, the voltage over here is definitely bigger than the voltage here. Okay, but the other thing to consider is also the current. Okay, over here the current is small, and over here the current is big. So if the current here is big, shouldn't the Q be bigger? Shouldn't the Q be brighter if the current is big? So, the big question lah, which one actually affects the brightness? Is it the current or is it the voltage? Okay, if you want, you can go and find out, go and read on the forums lah. It's quite interesting. Okay, purpose of using laminated iron core in a transformer. Okay, the laminated iron core is a solution to which problem? Louis?
B.
Okay, B, which is to reduce eddy current. Now remember, everybody, every single problem over here in a transformer, reduce resistance, prevent flux leakage, magnetize and demagnetize, dia punya solution is very specific. You cannot campur aduk. Okay, you cannot campur aduk. And you will understand this when we go into the paper 2 questions. Okay, you will realize that, oh, actually, dia memang sangat specific ini. And that makes it easier to remember. Of course, you have to remember lah. But it makes it easier to remember because, okay, ini. Dia macam suaikan lah. Okay, there's no way you can mix it up. You cannot mix it up. Okay, because different problem, different solution. Okay. Number 3, why is the core of the transformer made of soft iron? Melanie.
D.
Sorry?
Donkey.
Donkey. Okay. Yeah, guys, sorry if you're going to say B or D, I suggest you say boy or donkey lah. Okay, because I think maybe my ears have a problem, so I can't really differentiate the B and the D when you speak into the mic. Okay, soft iron is easily magnetized and demagnetized. Melanie, let me ask you further. Kalau ini transformer bahkan dia sentiasa magnetize and demagnetize banyak kali kan, akan menyebabkan apa?
Kejauhan. Hysteresis.
Hysteresis? No. How do you pronounce this? Dia sama dengan the word hysteria. So it's hysteresis. Hysteresis. Okay, it's hysteresis. And so the constant magnetizing and demagnetizing, okay, causes hysteresis, okay, which menyebabkan apa? Poor Melanie, she's being asked so many questions at one time. Apakah kesan daripada hysteresis?
Loss of energy.
Loss of energy because of?
Heat.
Okay, heat. So hysteresis causes loss of energy. Actually, all the 4 problems, okay, cause loss of energy in the form of heat. Eddy current, okay, is loss of energy in the form of heat. Okay, except for the flux leakage lah. Flux leakage bukan. Okay, resistance. High resistance causes heat. I have said this since chapter 3. Resistance causes heat. Resistance causes heat. Bila kamu menggeser tangan, bahkan your hands will feel hot. Okay, resistance always causes heat. So, eddy current causes heat. Magnetizing and demagnetizing will cause hysteresis, which will result in the loss of power in the form of heat. Okay, everything is loss of energy in heat. Okay, that's why, transformers are always very hot. All right, number 4. Now we finally come to Michelle. Michelle is like, I can't wait to answer number 4. Okay, Michelle, what's the answer?
D, 60 volts.
All right, D, 60 volts. Very nicely done. Number 5. Transformer connected to a cathode ray oscilloscope. Okay, the cathode ray oscilloscope is a device that you learned when you were in Form 3. I'm not sure how far you remember this. But it is like the machine in the hospital, the teet. Okay, it works around the same principle, but it basically shows you the current flow, okay, with respect to time. So which of the following wave traces is correct when the extra coil on the core is connected in series to the secondary coil? What do you think? You add some more coil. Mordecai.
C.
Okay, it will be C. Dia punya frequency tidak akan berubah, tapi the value of the current will be much bigger. This one, the value of the current is only 2 boxes. This one, the value of the current is 1, 2, 3, 4 boxes. Okay, so it's definitely higher current value, but the time doesn't change. Okay, masih lagi 2 kotak. So you see, 2 boxes, 2 boxes, 2 boxes, 2 boxes for every half cycle. Okay, number 6, diagram 25 shows a simple transformer. The bulb lights up with normal brightness. Okay, what happens if the AC input is replaced by a 3-volt battery? Okay, Iqbal, number 6, please.
A.
Okay, A, the bulb does not light up. Why does the bulb not light up? What is the explanation for this?
Battery itu direct ke?
Okay, the battery is a direct current source. No, don't laugh. It's correct. Battery is a direct current source. Okay, and the transformer only works, as I mentioned, the transformer only works if it is an AC, an alternating current source. Okay, very good. The bulb does not light up. Okay, number 7. After Iqbal is Shim. Shim, you cannot escape this, okay? You must answer.
C.
Okay, C. The copper wire must be low resistance, and then the function of the laminated and soft iron core must be to reduce eddy current. Again, to remind you that the function, the modification and the function is very specific. Okay, dia menyelesaikan masalah yang sangat spesifik. You cannot change it around. Okay. Valerisa, question number 8, please.
B.
Brightness of bulb P is bigger than brightness of bulb Q. Why?
Because yang P itu dia ada banyak coil dari Q.
Okay, very good. All right. P banyak coil means P banyak voltage. Okay, number 9. Wilson.
A.
Okay, A. Why?
Bigger current. No, bigger voltage.
Which one? instead of small resistance, bigger current, and bigger voltage, because that's confusing. Okay, it may be bigger current, it may be bigger voltage. But don't talk in terms of that. Talk in terms of
low resistance for the coil ka?
Low resistance for the coil. No, low resistance is correct. But I understand. Okay, so the reason why I wanted to ask this question is to, what if this is a structured question and then the question says, give a reason why. Why do you choose with a low resistance wire? What are you trying to solve? What problem are you trying to solve? We're not talking about low voltage, high voltage, low
Loss
current.
of heat energy.
Okay, loss of heat energy. So low resistance means less heat energy loss, which means less power loss. Okay, so that is kind of the flow that you need to, your mind needs to think in this flow. Don't think in terms of voltage and current anymore, because that is in chapter 3. Okay, but when we talk about power, transmission of power, penghantaran tenaga kan, we talk about power loss. Okay, so we use a low resistance wire to increase the efficiency of the transformer, okay, by reducing the power loss. This is the important thing. Okay, we use resistance so that we reduce the power loss. Very important. Okay, step down transformer, Wilson.
B.
Okay, B. Thank goodness there's no D. Otherwise, I'll be asking, which one are you answering? Okay, B. All right, B, because the number of turns will tell you whether it's a step down or step up. What is? Does anybody know what is this kind of transformer called? Where the number of turns are the same? Actually, I don't know lah. I don't think there's a name for this lah. It's called useless transformer. Because if the primary voltage and the secondary voltage is the same, right? For what you want to do this, just kasih sambung terus saja lah makan. Okay, so it's a useless transformer lah. No step transformer. Okay, I don't know lah. I don't know what you want to call it. It can be a no step transformer lah. Okay, Zulaika, 11 please.
C.
All right, very good. Okay, C, the number of turns. Okay, number of turns is a very big clue to tell us. Okay, last 4 questions. Is it? Oh no, ada banyak lagi. Okay, let's rush through this. Adam, 12.
A.
Sorry?
A.
A. The frequency of the induced current of the secondary coil increases. Wow, really? Step down transformer, when the current in the primary coil increases. The frequency of the induced current. Why would they suddenly talk about the increase, the frequency? No, it's not. Okay, it will be D. The magnetic field in the primary coil will increase. Okay, because the current in the primary coil increase. When we increase the current in the primary coil. Okay, everybody hold on now. Let me start this question number 12 and I will get back to you on this. Okay, I think there's something off with this question. Why would the magnetic field in the primary coil increase? Because it is the voltage that makes the difference. Interesting. Okay, let me come back to you on this. But I don't, definitely frequency of the induced current. Okay, it's interesting. But I'll come back to this later. Okay, Eliska, number 13, please.
B.
Okay, B, must be AC. Okay, all the way must be AC. Cannot be sekejap DC, sekejap cannot. DC doesn't work. Okay, number 14. I think Brandon. Yeah, no, Angeline. I always miss Angeline. Gosh, goodness. Sorry, number 14, Angeline, please.
A.
The function of the transformer in an electrical is to increase the power. No. Cannot. Power remains either the same or it is lost. It is not to increase the power. What is it? Can you try again? Think about the definition of the transformer. The transformer is either to increase or to decrease the...
B.
To reduce the resistance. No, not really. Oh no, are you going to answer everything? I did get it correct. It's C is to change the potential difference, otherwise known as the voltage. Okay, potential difference is also known as the voltage. The function of the transformer is to step up, is to increase or to decrease the output voltage. Okay, another word for output voltage is output potential difference. Okay, it is the same thing. Okay, be careful with this. All right, number 15. Now, Brandon.
C.
Okay, you change, why we use alternating current? Because the voltage, okay, can be changed by transformer. All right, last person, Damir. Oh, sana P, sana Q, sorry.
B.
B,
Boy.
Okay, which combination of this one is correct? Yeah, okay, because this one, dia mesti step up. So, dia mesti either this or this lah. Dan ini dia mesti step down. So it's either this or this. So ini dua saja yang ada dua-dua tick. Okay, so the answer will be boy. Okay, let's continue. Can we continue a little bit more? Let's answer one so that we don't have to answer so many tomorrow. Name the type of transformer. After this one is Daniel.
Step down.
Okay, very good. It is a step-down transformer. Why do we use soft iron? Okay, why? Why do we use soft iron? Elijah?
Because this is easy to be magnetized and demagnetized.
Very good. Okay, that is a very good answer. Easy to magnetize and demagnetize. A specific problem with a specific solution, which is why this topic, this subtopic actually is very simple. Because, there is only one solution. There's no other way around it. Itu saja. Okay, but of course it's tricky lah. Kalau kau salah satu, then you will wrong everything lah. Okay, B. The number of turns in the primary coil is 1000. Calculate the number of turns in the secondary coil. After Elijah is E, F, G, H, I, J, K, L. Irina.
25.
Okay, 25. Number of turns, there's no unit for it, sebab bilangan saja. Okay, so it will be 25. Make sure you substitute it correctly. Okay, understand that this, everybody, understand that this is actually the second step. The first step is VP over NP equals to VS over NS. Then dia sudah pindah-pindah sampai dia jadi begini. Please understand that this is the first one. This is the first step you should be looking at. Okay. Now we come to the question where we are talking about efficiency bukan 100%, 75%. Maybe the easier way is you start counting the input power first. Okay, the input power will be VP times IP because, oh no, sorry. So VP is given here, 240. Okay, it will be 240, okay, times the current in the primary coil is 0.1. Okay, so you will get, how much is that? Is it 2.24? 240 times 0.1. Yeah, okay, it's 24. So the input power, okay, is 24 watts. Okay, so then since the efficiency is 75%, right? So if you substitute into the formula, efficiency is 75 equals to output power, okay, over input power is 24 times 100. Okay, so then after that you pindah, and what you will get is, and I hope you got this lah, Isabella, okay, is 18 watts. Okay, so this is a shorter way of doing it lah. Dia terus kasih masuk. But if it helps, what you can do is you calculate it separately. Okay, calculate the input power and then put it into the efficiency, this one. Okay, the efficiency formula. Okay, so this is an example of a question where the transformer is not ideal. Okay, dia adalah 75%. Alright. Okay, suggest a modification for the transformer that enables the appliance to function correctly. Sorry, after Isabella is who? It should be Jacinta, right? Yeah, Jacinta, sorry.
The secondary coil is wound on the primary coil.
Okay, it can be secondary coil is wound on the primary coil. Hold on. Electrical appliance which needs 20 watts of power is connected to the transformer output. Suggest a modification to the transformer that enables the appliance to function correctly. What a strange question. Okay, but it says here laminated coil, low resistance coil, secondary coil is one on this one. Either one, all four also can. Okay, laminated iron core, soft iron core, low resistance coil. Secondary, the one that Jacinta chose is the one with the longest answer. Okay, the secondary coil is one on top of the primary coil. Also all can. Okay, sebenarnya keempat-empat tu boleh sebab dia hanya meminta satu modification. Okay, all right, let's call it a day for today. Tomorrow we will continue with the rest of the questions, and I would highly suggest that you take a look at especially the section B and section C questions lah. Okay, questions like this. Okay, this is a contour of a section B question, making a choice. This is a modification question, section C question. Okay, so again, put your answer in the form of a table. Okay, this is a section B question, membuat pilihan yang sesuai. This is a question, question number 7, is a little bit different lah. Dia lain sedikit daripada our standard section B question. Okay, but we will answer all this tomorrow lah. Okay, hopefully we have enough time to answer this. This one, okay, I'm not sure, is this question inside your book? Okay, because actually this should be a 4.1 question, but okay, let's see lah if we can have time to answer tomorrow. Okay.